So today we're going to work on graphing our polynomial equations, and we're going to use synthetic division to help us get there. For problem 1, we have the equation x cubed minus 3x squared minus 10x plus 24. So the first thing I want to make observations of is our leading term, because this is going to help us identify the end behavior when we go to graph it. This is going to give us an idea of how our sketch is going to turn out. So here's my leading term. I have x cubed, and we want to know, is the highest degree even or odd? And we know that 3 is an odd number, so we're going to write odd there. And then we want to know, is the leading coefficient positive or negative? So we look in front of the x here of the x cubed. There's no negative symbol there, so we know that it is positive. And we go back in the recesses of our minds and we say, okay, so if it is odd and positive, what is the right-hand side going to be doing? And we know the right-hand side will go up and the left-hand side will go down. Okay, so the first piece of the puzzle is done. We made our observations about the leading term. We made some conclusions about what the end behavior of our graph is going to look like. And now let's go ahead and move down and work on our synthetic division so we can work towards getting our 3x intercepts to be able to begin to plot this cubic equation. So to do our synthetic division, remember we write our coefficients and the constant in our synthetic division box here. So we have 1, -3, -10, 24. Our x-intercept is 4. We start by bringing the 1 straight down. 1 came outside the box, so we times that by the 4 that's off here onto the side. So we say 1 times 4 is 4. We add that together. -3 plus 4 is 1. 1 came outside the box, so we times that by the number off to the side over here, that 4. So 1 times 4 is 4 yet again. We add straight down. -10 plus 4 is -6. -6 came outside the box, so we times that by the 4 off to the left-hand side over here. So we say -6 times 4 is -24. We add that straight together. 24 plus -24 is 0. And remember what we talked about previously is when we're doing synthetic division and I give you a root or an x-intercept and I tell you to use that in our x-intercept, you must get a 0 on the end. If we know that this is a root or an x-intercept, you must get a 0 on the end. And if you didn't, I'd like for you to go back and check your math, make sure those negatives are in the proper locations, because that's what we need to make sure is happening. Now, x cubed was the highest degree. 3 was the highest degree. So remember when we're writing our new equation, we go 1 less than that. So the first number is the coefficient to x squared. The second number is the coefficient to x, and then we just have our constant. So our quadratic equation is 1x squared plus 1x minus 6. And now we factor that. What is going to multiply to give us -6? So we got to think of, multiply. We got to think of some numbers that will multiply to give us a -6, and that adds to 1. Now, if you're thinking to yourself, that's +3 and -2, you are correct. So that would factor out to be x plus 3, x minus 2. And just to be clear again, we asked what multiplied to -6 and added to the negative number. So I just want to kind of show this to you. 3 times -2, 3 times 2 is 6, 1's positive, 1's negative, so we get -6. So when we multiply them, we got -6. And when I add these two numbers, 3 plus -2, we got 1, which is what we wanted for the middle number. So that's where this +3 and -2 came from. We were able to figure that out from the puzzle. We set these both equal to 0 and we solve them. And the beauty of solving just these simple one-step equations with the addition and subtraction, it's just the opposite. So my x plus 3 gives me an x-intercept of -3. My x minus 2 gives me an x-intercept of +2. So those are my 3 x-intercepts, 4, -3, and 2. And we know the right-hand side is going up and the left-hand side is going down. I do need to clear this to scroll down. So I want you to make sure you can pause the video right now if you need to. Make sure you have all the pertinent information written down, and then you can go ahead and start the graph. So scrolling down, we said our three x-intercepts were 4, -3, and +2. So we were able to plot our x-intercepts by taking those three x-intercepts and putting dots right where the numbers were on the x-axis. And now let's do our end behavior. So the end behavior says the right-hand side is going to go up. So I'm going to go to the furthest most right point here, which is the 4. That's as far right as I can go. And I'm going to draw an arrow going in the upper right-hand direction. We also established that the left-hand side was going to be going down. So from the furthest most left point, we're going to draw an arrow going down to the lower left. So from -3, we draw an arrow going to the left. Now, remember yesterday, we said the x-axis here, this is like a wall. You cannot cross the wall unless you go through a door, right? If you're in one room and you want to walk to another room, you have to go through a doorway. You can't go through a wall. So the x-axis is like a wall, and my x-intercepts are the doors through the walls. So in order to go from one room to the next, you have to weave through the doorways to get from one room to the next. And you're just going to weave back and forth through those points. And at this point right now, we don't care how high or how low these little bumps go, because we're just giving a general sketch of our polynomial equations. And that is just a sketch right there of our function. I'm going to clear this away and I'm going to scroll down to the second problem. The second problem here is a little bit different. Again, we're going to start by observing the leading coefficient. The leading term here, to be able to make some conclusions about the end behavior of our graphs. So looking at the leading term, we have -x³. So we want to say, is the highest degree even or odd? Looking at that degree, looking at the exponent, that's a 3. 3 is an odd number. So I know the highest degree is odd. Is the leading coefficient positive or negative? Well, the leading coefficient is the number that's in front of our x. I look in front of the x here, that's a negative symbol. So I know the leading coefficient is going to be negative. Now, we had learned this previously. We have to identify now what is the end behavior of our graph going to be. If it's an odd exponent with a negative leading coefficient, that means the right-hand side is going to go down and the left-hand side is going to go up. Okay, now let's do our synthetic division to be able to fully factor this cubic equation. So we start by writing our coefficients and our constants in our synthetic division box. And we see that our x-intercept here is 5. So I'm going to draw a 5 on my little sidebar to the left. And now we do our synthetic division. We start our synthetic division by bringing the first number straight down. -1 gets brought straight down. -1 came outside the box. So we have to times it by the number on the left. So -1 times 5 is -5. We always add straight down, right? Whenever we have two numbers in the column, we add straight down. So 5 plus -5 is 3. We multiply, 3 came outside the box, so we multiply that by the number on the left-hand side. So 3 times 5 is 15. We add them together. -17 plus 15 is -2. -2 came outside the box, so we're going to take that and multiply that by the number on the left, which is 5. -2 times 5 is -10. We add those two numbers together and we get 0. Now, again, I want you to observe. I told you 5 was an x-intercept. So when we know that as a fact, we know that the last number should turn out to be 0. If when you were solving this using synthetic division, you did not get 0, I want you to go back and check your math. Make sure you have all your positives and negatives correct. 8 plus -5 is 3, not negative 13 or something along those lines. So just make sure you're careful with that. Multiply, add, multiply, add, multiply, add, so on and so forth, right? Okay, so now we know this is our new quadratic equation. The first number is x squared, so negative 1x squared plus 3x minus 2. I'm going to write this above here. So I've got negative x squared plus 3x minus 2. Now, instinct might have you already asking, okay, what multiplies to negative 2 and adds to 3? And then you're not going to be able to think of something, and you're going to kind of get a little bit confused. And uh-oh, Miss Eaton, you messed up. You can't factor that. You should have given us a factorable problem. But the truth is, that's not how we do this problem, because there is something in front of this x squared. And remember, when we have something other than 1 in front of x squared, we have to approach the factoring process a little differently. Now, normally, if it was a 2 or a 7 or something in front of x squared, we would take the first number and last number and we would multiply them. And we would say, okay, negative 1 times 2 is 2. And then we say what multiplies to 2 and adds to 3. But because it's simply a negative, I want to make life even easier for us. And here's what I want to do. Since this is a negative, we can factor out that negative 1, which means that the signs of everything on the inside is going to change. So really what you're factoring is x squared minus 3x plus 2. So now you can say, what multiplies to 2 and adds to negative 3? So that's the game that we're playing here. What numbers, you got to think of two numbers that multiply. When we multiply them together, we get 2. And when I add them together, I get negative 3. So if you thought of negative 1 times negative 2, you are correct, because a negative times a negative is a positive, and 1 times 2 is 2. So when I multiply negative 1 times negative 2, I get 2. If I add them, negative 1 plus negative 2, that's going to give me negative 3. So we found the winner here. It's negative 1 and negative 2. So we write that as x minus 1, x minus 2, and we set those equal to 0. And when we solve those, minus 2 equals 0. When we solve those, we get x equals 1 and x equals 2. And those are our two x-intercepts. Now I want to go down and I want to graph these 3 points, and I want to give us a sketch of our cubic equation here, but I do have to clear this information out. So if you need to continue writing, I want you to pause the video right here, finish writing, and then we'll move on to graphing the cubic equation together. Okay, so I'm going to scroll down to graphing here. We had our 3 x-intercepts. The first x-intercept that we had was 5. The second x-intercept we had was 1. And the third x-intercept we had was 2. You can look above your paper here as to what your end behavior was. The right-hand side, remember, because it was odd and negative, was going to go in the downward direction. And the left-hand side was going to go in the upward direction. So you have to pay close attention to the end behavior here. Remember, these dots are the doors. So we want to just kind of weave between the rooms, going through the doors. And again, we're not worried about how high or how low we're going right now, because this is just a sketch of our polynomial equation. But there's a general idea of what your polynomial equation might look like. Okay, moving on to problem 3. So problem 3 is slightly different. Whoopsie daisies. Problem 3 is slightly different. And I'm actually going to zoom out a little bit here because I want to be able to fit my second synthetic division box in. So I hope that's not too small. But here we go. We have our polynomial equation. We see that the leading term here is x to the 4th. So we're switching it up a little bit. So that's my leading term. And we say, okay, in the leading term, is the highest degree even or odd? And here's where I said we're switching it up. We notice that it's x to the 4th, which is an even number. That's an even number. So things are going to be a little bit different with our end behavior. And is the leading coefficient positive or negative? So I look in front of the x, of my x to the fourth, I see no negative sign. So I know that it is positive. It's positive here. So what does that mean? If it's even and positive, we know even means both the right and left-hand side are going to do the same thing, and positive means they're both going to be pointing up. So in the end, my right-hand side is going to go in the upward direction, and my left-hand side is going to go in the upward direction. All right, let's get to factoring to find our two x-intercepts. Notice it's x to the fourth. So I'm going to have 1, 2, 3, 4 x-intercepts, one for each of the x values there in the equation, right? So just grabbing my eraser here. I don't want them to be confused with x-intercepts. All right, so we're going to do our synthetic division to get us started. So we have 1x to the fourth, 5x cubed, negative 25x squared, negative 65x, and positive 84. Now, to draw our number on the left-hand side, you can use either x-intercept. It doesn't matter which one you start with. But as you can see, we're going to have to do a second synthetic division. So if we choose to use the one here, that when we go to do synthetic division for the second one, you have to use 4 in the second one. You can't use 1 twice. So you have to use 1 for the top synthetic division and 1 for the second synthetic division. It doesn't, I could have very well used 4 to start off with on the top and 1 on the bottom. It does not matter. Okay, so here I am going to do my synthetic division. Bring my 1 straight down. 1 times 1 is 1. Add those together. 5 plus 1 is 6. 6 times 1 is 6. Add those together. Negative 25 plus 6 is negative 19. Negative 19 plus negative 65 is negative 84. Negative 84 times 1 is negative 84. 84 plus negative 84 is 0. Now, think about what we did. I'm going to draw something in here, but then I'm going to erase it. So I don't want you to draw along with me here. If we have x to the fourth here, and I was turning this into a new equation, I would go 1 less than x to the fourth. So I would get 1x to the third plus 6x squared minus 19x minus 84. And what's our end goal here? We want to find our x-intercepts. We want to try and factor that. And we can't do that the way we have it set up. So what we need to do is we need to do a second synthetic division, which is actually not bad to do because we like synthetic division and we're good at it. So we just literally take the numbers that we just got in our synthetic division and we move them down to a second synthetic division box. So we get 1, 6, negative 19, negative 84, and then we do synthetic division again. So we have 1 times 4 is 4, add those together, 6 plus 4 is 10, 4 times 10 is 40, add those together, negative 19 plus 40 is 21, 21 times 4 is 84, add those together, and we get 0. So again, 0 on the ends. Notice we got a 0 here, and we get a 0 here, and this becomes my new quadratic equation. And that's something we can factor without using our synthetic division. So we say, what's going to multiply to 21 and add to 10? Well, there's not too many numbers that multiply to 21. Hopefully you're thinking of 7 and 3 and you think to yourself, oh, 7 times 3 is 10. So boom, we found our last two x-intercepts, which are negative 3, x equals negative 3, and x equals negative 7. So we're going to throw that here on our x-intercept lines. Negative 3, 0, and negative 7, 0. And now, again, I do have to clear this out so that I can scroll down to the graph so that we're able to graph this together. This is the first time that we'll be graphing a quartic equation. So if you need to pause and finish writing, please pause the video right here. And then you can press play when you're ready to go down to graphing. All right, I'm going to zoom in a little bit because that's teeny tiny after I zoomed out. So we have to plot our x-intercepts now. We said we were given that 1 is an x-intercept. We were given that 4 is an x-intercept. We found -3 to be an x-intercept, and we found -7 to be an x-intercept. The right-hand side is going up. The left-hand side is going up. So it's a little different from the other ones that we've graphed so far. Now, remember, we want to weave in and out of our x-intercepts from the positive side of the x-axis and then down to the negative side and so on and so forth. So weaving in and out of those doors, those x-intercepts. And here is a general sketch of what your quartic equation would look like. Okay, I'm going to go ahead and clear that out. I'm going to scroll on down. Again, I'm going to zoom out so I can get the second synthetic division bar in there. And here we go. Let's do our last problem together. So we have our leading term is x to the 4th again, right? So we know that's an even exponent, and we look in front of the x and it's positive. The right-hand side's going to go up. The left-hand side's going to go up. And we do our synthetic division. So 1, -7, -27, 63, and 162, not 26. 162. And these are my two x-intercepts. We've got 9 and -3. And remember, you have to use each one of them. So I'm going to use 9 for the top one and then -3 for the bottom one. So here we go. We're doing our synthetic division. Bring the 1 straight down. 1 times 9 is 9. Add that together, we get 2. 9 times 2 is 18. We add that together, we get -9. 9 times -9 is -81. We add that together, we get -18. -18 times 9 is -162. We add that together, we get 0, which is what we wanted. Now remember, because this was a quartic equation, we've got to do synthetic division twice. So these numbers are just going to get brought straight down. And then we do synthetic division all over again. So 1 gets brought straight down. 1 times -3 is -3. Add those together, we get -1. -1 times -3 becomes +3. We add those together, we get -6. -3 times -6 is a +18 because a negative times a negative is a positive. Add those together, we get 0. And our next equation is x squared minus x minus 6. So we say what multiplies to -6 and adds to -1. And hopefully you said, oh, -3 and +2. -3 times 2 is -6. -3 plus 2 is -1. So if we were to set each of those equal to 0, so x minus 3 equaling 0 and x plus 2 equaling 0, we would get x equals 3 and x equals -2. So we've got 3, 0 and -2, 0. So I do have to clear that out. So make a note of that for yourself, what your x-intercepts are. So we have 9, 0, -3, 0, 3, 0, and -2, 0. And then it's going to go up, up. All right. If you need to pause the video right here, go ahead. And now let's go ahead down and graph this. And let me zoom in again because I zoomed out so far that it got really tiny. All right. So again, let's go ahead and plot our x-intercepts. So our first one that was given was 9. The second one that was given was -3. And the two that we found were 3 and -2. So the right-hand side goes up, the left-hand side goes up based on our end behavior and what we had observed, right? And then we're going to weave through the point, weave through the point, weave through the point, and weave through the point. And there is a general idea of what your quartic equation would look like once we plot it on the graph.